Just like number 30 told me that I was in the second quadrant, this one is telling me that theta is between pi and 3 pi over 2. So here's pi, 3 pi over 2 is here. That's telling me I'm in the third quadrant. That means both sine and cosine are negative, but tangent will be positive. Right? My x is my cosine, which is negative. My y is my sine, which is negative, but tangent is y over x. So it will be negative divided by negative. It will be a positive. So I'm still going to use this relationship, sine squared of theta plus cosine squared of theta equals 1. And I know that my cosine is negative 3 over 5, and I'm going to square that. So I might want to leave this all as fractions. So if I square this, I get positive 9 over 25. I'm going to subtract that on both sides. So I get sine squared of theta equals, remember that 1 is really 25 over 25. So 25 over 25 minus 9 over 25 is 16 over 25. And then when I square root both sides, I get that sine of theta equals 4 over 5. Now, even though our answer says positive 4 over 5, we know that this is in the third quadrant. So I actually know that the value of sine of theta in that quadrant is negative 4 over 5. And remember, for the second part here, tangent is sine over cosine. So I'm going to take this sine value, this negative 4 over 5, and I'm going to divide it by my cosine value given up here, negative 3 over 5. And remember, when you divide fractions, you keep, change, flip. So we're going to keep the first fraction. We're going to change this division sign to multiplying, and we're going to flip the second fraction. So these cancel, the negatives cancel, and the answer to tangent of theta is 4 over 3. There's another way you could think about doing this. If you were to draw a triangle here in the third quadrant, if you know that cosine of theta is negative 3 over 5, remember cosine is it's adjacent, this side, so that's negative 3 over the hypotenuse, which is that side, which is 5. Now you could just use the Pythagorean theorem, which is just the same thing as this. This is the Pythagorean theorem. And you would find that this is a special right triangle. It's a 3, 4, 5. So you would find that this is a 4. Now, since it's going this way, we know it's a negative 4. Once you get that triangle labeled, then you can see that the sine, I switched these. My theta is here, right? So cosine would be negative 3. This side is adjacent. And this side is opposite. So my cosine would have been negative 3 here, 5 here, and which means that this one's the 4. So you can see that my sine is the opposite over the adjacent. It's negative 4 over 5. And you can also see that tangent is opposite over adjacent. It's going to end up being positive 4 over 3. So if you don't like all this fraction work, you can draw yourself a triangle and use just the Pythagorean theorem with it.